it became, this is probably the most important part of all of our equilibrium stuff. So we do equilibrium with gases right now. We do acid bases. We do something called solubility, product constant. It will all be ice tables. Okay, and they're just same thing as BCA tables. Before, change, after. Now it's going to be, ice is going to be in what's there initially. Okay, what pressures or molarities are there initially of these things? What's the change as the reaction goes and reaches equilibrium? And what is there at equilibrium? Remember, your K value is based on the value at equilibrium. K value is not what's there initially. It's not the change. Your K value is what is there at equilibrium. So here it's telling us we put 4.29 atmospheres of PCl3. So we're starting with 4.29 atmospheres of that. And 4.29 atmospheres of that are placed in a container until the equilibrium is established. Okay, so there's none of that to start with. Let it go until it reaches equilibrium. The equilibrium pressure of PCl5 is 2.59 atmospheres. So we know at equilibrium, this value is 2.59 atmospheres. Went from 0 to 2.59. So we know this went up by 2.59. That means this went down by 2.59 because it is a 1-to-1 ratio. And this went down by 2.59 atmospheres. So at equilibrium, this is 1.7 atmospheres. This is 1.7 atmospheres. Excuse me. And this is 2.59 atmospheres. So remember, at equilibrium, those are going to stay consistent. We're still making some of this, but at the same time that we're making some of that, we're going back and making some of that. So our K value would be Kp. K in terms of pressure would be PCl 5 to the first over the pressure of PCl3 and pressure of Cl2. So 1.7, 1.7. Our K value here is 0.896. Remember, a bigger K value means favors more towards the products. All right. I'll do one more ice table. These are pretty easy to do. They get a little bit harder in terms of some other things, but here's usually the deal. We're either getting values and figuring out Kp, or they're going to give us the K value, and we're going to figure out what are the equilibrium values. So these today are just getting the equilibrium values and figuring out K. Eventually, I'll give you the K value. You figure out how much stuff would be there at equilibrium. All right. Let's go here. I'll do this one other one. So there's our reaction. I'll write that down here. 2NO plus Br2 in equilibrium with 2NOBr. Initial change equilibrium. So at a given temperature, 1.6 atmospheres of NO, 1.6 atmospheres of Br2 are added. So we have 1.6 of that, 1.6 of that. Again, our K could be in terms of pressure or in molarity. And the equilibrium pressure of NOBr is found to be 0.53 atmospheres. So pretty similar to the last one. This is nothing. At equilibrium, this is 0.53 atmospheres. So we know this went up by 0.53. There's our change there. Well, these both had to go down. Notice 2 to 2 ratio. So if this went up by 0.53, this went down by 0.53. So at equilibrium, this one is 1.07 atmospheres. But this is a 2 to 1 ratio, or this is a 2 to 1 ratio. So this is going to be half. The change is going to be half what that was. So this is going down by 0.265, and at equilibrium, it would be 1.335 atmospheres. So if we were to get our K value, K in terms of pressure, NOBr's pressure at equilibrium, 0.53 squared, because it has a 2 in front of it, over the pressure of NO squared, 1.07, times the pressure of Br2 to the first, 1.335. So your K value is always based on your equilibrium values. K is always based on your equilibrium values. And the K there is 0.184. No label for K. Never a label for K on these things as we're doing things. All right.